Number 7 is similar to number 6 with one exception, and we're going to see here in a second what that might be. So it says a container has 10 chocolate chip and 6 peanut butter cookies. So let's see here. We got 10 chocolate chip, and then we've got 6 peanut butter. So in my little cookie jar, I've got 10 chocolate chip, and then I've got 6 peanut butter. So I've got a total of 16 cookies here in my cookie jar. And then what it's saying is what is the probability that the first cookie is a chocolate chip and the second is a peanut butter? So in terms of our probability, we're saying what's the probability that the first is going to be chocolate chip, and then the probability that the second would be peanut butter. Well, notice in this case, it didn't say that the chocolate chips were in one jar and then the peanut butter was in another jar. What we're saying is that all of them are in the same container, which is different than the last problem. In the last problem, we had 2 different marble bags. So what happens is that when I reach into this bag and grab a marble, that doesn't have anything to do with what's happening in this bag, right? So these are, since they're separate containers, they're what we call independent events. That what happens with me picking something out of this bag has nothing to do with what's going to happen out of that bag. Now, what's different is if you have one container, this is where it's going to be a dependent event because all of your items are in the same container. So if I say, well, what's the probability of me getting a chocolate chip? Well, there's 10 chocolate chip out of a total of 16 cookies. But then where this changes is that once I've now eaten one of those chocolate chips, there's now one less because I ate it. And so, or I took it out of the cookie jar, right? So now if I took a chocolate chip out of the cookie jar, now there's only a total of 15 cookies. So if I said, what's the probability of me getting a peanut butter? Well, there's 6 peanut butter, but it's not going to be out of 16 because I've already taken one cookie out of the jar. It's going to be out of 15, right? So again, the difference there, and as compared to the last one, is that we had 2 separate containers. So what I took out of one bag did not affect or impact what happens out of the second bag. But in this case, we're saying they're in the same container, so when you take one out, you now have one less. So we have to kind of update our tally there. Now once we have our 2 fractions, now we can just do some cross-canceling. Right, 10 doesn't go into 15, but 5 goes into both of them. 6 doesn't go into 16, but we can divide both by 2. And it looks like we can still do 2 ways you could do this. You can actually keep canceling. You could multiply across, you'd get 6 over 24, right, which would reduce down to 1/4. Or if you wanted to, you could cancel the 3's. 2 goes into 8 4 times, and you end up with 1/4. So you end up getting the same thing. So the probability of this happening would be 1/4 or 25%. Right? That's another way that we could say that. Right? And you know, because 1/4 a quarter, you know, a quarter is 25 cents. If you didn't believe me, 1 divided by 4, you get 0.25 or 25%. Right? All right. So the difference there between an independent event and a dependent event. Are there 2 containers or is there 1 container? Right. All right, so go ahead and try number 7 on the right, and then we're almost done.